The topic of the video is scattering cross sections in quantum mechanics. The deviation of some form of radiation or sound or straight moving particles from a straight trajectory to one or more paths due to the presence of a target in a medium through which these pass is called scattering. So we can represent the scattering process as shown in this figure. So we have got some incident particles or waves, and then there is actually a target, and we are showing that it is the incident particles are actually kind of scattered through some direction, in a direction like this. If the number of incident particles per unit area, which is normal to the direction of propagation of the particles per unit time, which is also called the flux of incident particles, is J sub incident INC. And if the number of particles which are scattered along a direction theta phi per unit time is delta n theta phi, then we can actually kind of define certain definitions like the differential scattering cross section and the total scattering cross section. But here we should actually know that the angle theta is the angle made by this direction, direction vector with the z direction, which we're considering as the direction of incident particles. And then here we can actually define a plane which is called the scattering plane, in which this vector actually lies, and the angle between this scattering plane and some reference plane is actually taken as angle phi. So in 3 dimensions some direction vector can be specified using two angles, for example theta and phi. And then as I said, here we can define the differential scattering cross section, which we can abbreviate as DSC, and it's denoted by this d sigma by d omega. And here we should not actually kind of get confused that it's actually a differentiation or something, but it's just a notation. And the definition of that is delta n, which are the number of particles per unit time scattered along theta phi direction, divided by the flux of incident particles J sub INC, and d omega, which is the solid angle which we have considered in the direction of theta phi over here. And then the total scattering cross section is just the integration of this DSC over all solid angles d omega. And since in spherical polar coordinates d omega is equals to sine theta into d theta into d phi, we can even write this integral as a double integral for both theta and phi, and then we should write sine theta into d theta into d phi. So we get sigma by doing these integrals like this. So this is our total scattering cross section, and that's it in this video, and thanks for watching.